Alright, so this video is going to be part 3 of our limit comparison test practice. Okay, so we want to determine if the series converges or diverges using the limit comparison test, and we've been given the series of the sum from n equals 1 to infinity of 2n cubed plus 7 over n to the 4th sine squared n. Okay, now I haven't really been discussing this part, but you do want to make sure that all of your terms of your series are going to be positive. Okay, that's how this only applies. The limit comparison test only applies when the terms of your series are positive. Okay, and you can see here that we will end up getting positive terms, and by terms I hope you know I mean 1/2 plus 2/3 plus 4/5, something like that. Like, these are terms. I'm not talking about like terms in here or anything like that. Okay, now we need to have positive terms for this test to apply. And you can see here that these are all going to be positive. Sine squared n, that goes in between 0 and 1, not negative 1 and 1, because it's being squared. Okay? N to the 4th, well, this is of course going to be positive. N to the 3rd, that will be positive because we are inputting positive values of n. We're adding 7, so we will get positive terms, and we can apply the limit comparison test. But we got to figure out what we can compare to here, okay? So first, dealing with our numerator here, we of course can just get rid of that constant. All right, well, let's get rid of that constant, make it a little easier on ourselves. We're left with 2n cubed on the top. All right, well, on the bottom here, we have n to the 4th sine squared n, and that sine squared n, that's just going to give us a bunch of trouble. So it'd be nice if we could compare it to something that didn't have the sine squared n in it. So let's just compare it to n to the 4th on the bottom. Now this simplifies down to, well, 2 over n, which we know, if you take out that 2, that's the harmonic series right there, and that diverges, okay? So now we have to take our limit, and of course we want the product of our limit to be finite and positive, okay? If it's finite and positive, great. Then we know that either both these series converge or both these series diverge, and of course it would be both these series diverge because we know that this series diverges. Alright, so take the limit as n approaches infinity of, we have a 2n cubed plus 7 here, over n to the 4th sine squared n. It's going to be over 2 over n, okay? And of course we can flip this n up to the top, this 2 will go to the denominator. We get the limit as n approaches infinity of 2n to the 4th plus 7n. Alright, multiplying that n through here. And we have a 2n to the 4th sine squared n. So now we got to take a look at this limit. And of course, you probably know by now just to look at the highest power of n in your limit. Okay, the 7n, that's not going to matter at all. And, you know, of course, if you divide everything by n to the 4th, you'll see that. But just kind of skipping steps here. We have 2n to the 4th over 2n to the 4th sine squared n. And if we could eliminate this sine squared n, that would be perfect because we would just have a 2n to the 4th over 2n to the 4th. We know that's 1. Okay? So think about this sine squared n. The values range between 0 and 1. As these n's get really, really, really big, this sine squared n is going to matter less and less and less. So we're actually going to be able to just cross that out. And we get our limit equal to 1. Now 1 is, of course, greater than 0 and finite. And that means that we can say that either these both diverge or they both converge. And of course, this diverges, so they both diverge. So the series is divergent by the limit comparison test. And that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the limit comparison test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.